Hello students, welcome to EPG Pathshala. I am Dr. Dipendra Sharma from MIT University, Gurgaon. Students, today we are going to talk on module Hypothesis Testing, Developing Null and Alternative Hypothesis under the paper Quantitative Techniques for Management Decisions. After the completion of this module, the students are expected to understand the concept of the null and the alternative hypothesis. They should also be able to understand that how are they going to develop the null and alternative hypothesis about the population parameter. Now the rationale for the hypothesis, what is it? It should also be clarified to you once you have completed this particular module. Under this module, students, we are also going to discuss about the various formats of the hypothesis. Now, in order to introduce you the basic concepts, let us start that there are three techniques of the inferential statistics. What is inferential statistics? If you remember, in one of the introductory module, we have discussed that statistics can be divided into two broad categories, that is, a descriptive statistics and the inferential statistics. So in the inferential statistics, there are three techniques, which are a point estimate, confidence interval, and the degree of freedom associated with the parameter value which lies within the interval values. It helps decision makers in determining an interval estimate of a population parameter's value with the help of sample statistics along with certain level of confidence of the interval containing those values. Another method to determine the true value of population parameter is to validate the claim, which is also called belief, assumptions, or the statement, and it is basically known as a hypothesis made about this true value by using a sample statistic. So the next topic that we are going to discuss is about hypothesis and the hypothesis testing. A statistical hypothesis, which is also known as assertion, statement, belief, or assumption, is about an unknown population parameter is tested and analyzed based on simple data. Accordingly, the hypothesized value of a population parameter is either not rejected or rejected. The method of testing the validity of one's claim by evaluating the difference between the value of sample statistics and the corresponding hypothesized population parameter value is known as a hypothesis testing. Let us discuss few examples of hypothesis. For example, the first example reads, a judge assumes that a person charged with a crime is innocent and subject this assumption, or what we also know as a hypothesis, to the verification by reviewing the evidence and hearing testimony before reaching to a verdict. Similarly, a medicine manufacturing organization which makes a claim that 96% of all the persons suffering from the said disease get cured by using its particular medicine. An investment company which makes a claim that the average return across all its investment is 25% and so on. So these are the hypotheses, or these are the assumptions, or these are the claims which are being made, and this is what we need to verify with the help of the hypothesis testing. Next, we will discuss about the formats of hypothesis. As we have stated earlier, a hypothesis is a statement which uses sample statistics to test about the true value of population parameters, to examine whether any significant difference exists or not between the true value of population parameters and sample statistics. Any hypothesis can be written in the form of if-then statement. For example, if inflation rate has increased, then wholesale price index will also increase. If employees are unhealthy, then they may take sick leave more frequently. Hypothesis, which involves terms such as positive, negative, more than, or less than, is called directional hypothesis. This is another type of hypothesis that we are discussing other than the if-then hypothesis, and it indicates the direction of the relationship between two or more populations under the study with respect to a parameter value as illustrated on this next page. For example, side effects of a particular medicine were experienced by less than 20% of people. Second example reads, greater stress causes lower job satisfaction to employees in any organization. The non-directional hypothesis indicates the relationship but does not indicate the direction of relationship. So this is the third type of hypothesis that we are discussing. In other words, there may be a significant relationship between two populations with respect to a parameter. Even then, nothing can be said whether the relationship would be positive or negative. Similarly, if two populations differ with respect to a parameter, nothing can be said whether parameter value of any population will be more or less. The following example will make this non-directional hypothesis more clear. Let us take number 1, the relationship between age and sick leaves. So as we see that there may be a relationship between the age and the number of sick leaves taken, but we cannot tell about the direction whether they are going to increase, whether it increases or whether it reduces. The second example reads, the difference between the average heartbeats of men and women. So again, the point that we want to bring to your notice is that there may be a relationship between the heartbeats and of a man and a man. But by this hypothesis, we are not able to tell about whether it is more or less. Therefore, they have been categorized as non-directional hypothesis. Let us now see what is the rationale behind the hypothesis testing. If a hypothesis claim or assumption is made about a specific value of a population parameter, then it is expected that the corresponding sample statistic is close to the hypothesized parameter value. It is possible only when the hypothesized parameter value is, I repeat, it is possible only when the hypothesized parameter value is reasonably close to true value of parameter and the sample statistic turns out to be a good estimator of the parameter value. This approach to test a hypothesis is called a test statistic. Since sample statistics are random variables, therefore their sampling distribution shows the tendency of variation. Consequently, sample statistic value is not expected to be exactly equal to the hypothesized parameter value. The difference, if any, is due to a chance or a sampling error. But if the value of the sample statistics differ significantly from the hypothesized parameter value, then hypothesized parameter value may not be correct, and it increases the doubt about the correctness of the hypothesis. Students, in statistical analysis, the difference between the value of sample statistic and the hypothesized parameter is specified in terms of probability, whether the particular level of difference is significant or not. The probability that a particular level of difference exists by chance can be calculated from the known sampling distribution of the test statistic. The probability of concluding that the observed difference between the test statistic value and the hypothesized parameter value cannot be due to chance is called the level of significance of that test. Let us discuss a very important concept related to hypothesis, that is a null hypothesis. What is a null hypothesis? A null hypothesis is a statement that tells that there is no real difference in the sample and the population with respect to the issue under consideration. It maintains the status quo. If the null hypothesis is not rejected, no changes will be made. It is denoted by H0. It represents the claim or statement made about the value or range of values of the population parameters. The capital H represents or stands for hypothesis, and the subscript 0, which is also known as not, implies no difference between sample statistics and the parameter value. Thus, hypothesis testing requires that the null hypothesis is considered true, that is, status quo is maintained, or there is no difference between them, until it is proved false on the basis of the results derived from the sample data. The null hypothesis is expressed using the mathematical sign less than equal to, or greater than equal to make a claim about a specific value of the population parameters. For example, we may write the null hypothesis as H naught, where mu is less than equal to, or greater than the mu naught, where mu is the population mean and mu naught or mu 0 represents the hypothesized value of mu. Only one sign out of the three signs that we are discussing, less than equal to, or greater than equal to, will appear at a time when we are going to state any particular null hypothesis of a given situation. Related to null hypothesis, we also need to develop another hypothesis which is known as an alternative hypothesis. An alternative hypothesis is one in which some difference is expected. It specifies those values that are believed to hold true and which is expected to hold the truth. Accepting the alternative hypothesis will lead to the changes in opinions or actions. Thus, the alternative hypothesis is just the opposite of the null hypothesis that we have just discussed. It is denoted by HA. It is the counterclaim or statement made against the value or range of values of the population parameter. Thus, an alternative hypothesis represents the claim that a specific value or range of values of the population parameter is not equal to the value claimed in the null hypothesis and is written as HA, that is alternative hypothesis mu is not equal to mu naught, or null hypothesis mu is less than mu naught or it is greater than mu naught. Consequently, each of the following statements is an example of null hypothesis and the alternative hypothesis. For example, if we are taking null hypothesis where we are assuming that mu is equal to mu naught, then the alternative hypothesis for such null hypothesis will be that mu is not equal to mu naught. In the second case, if we are assuming that the null hypothesis mu is less than equal to mu naught, then the relatively alternative hypothesis will read as mu is greater than mu naught. Third condition, if the hypothesis which is null says that mu is greater than equal to mu naught, the alternative hypothesis for such type of null hypothesis will be mu is less than mu naught. So, as a general principle, whatever that needs to be established is placed in the alternative hypothesis, whereas the null hypothesis will always include the status quo. The null hypothesis regarding the population parameter of interest is specified with either of the symbols like equal to, greater than, or less than equal to, and the corresponding alternative hypothesis is then specified of the signs like not equal to, less than, or greater than. Students, here it is important to note that it is always the null hypothesis that is tested. The null hypothesis refers to a specified value of population parameter, which may be mu, sigma, or pi, and not of the sample statistic. Secondly, this is a very important point that a null hypothesis can either be rejected or not rejected, but it can never be accepted just based on a single test. Thus, a statistical test can have one of the two outputs, that is, the null hypothesis is rejected and the alternative hypothesis is accepted, or that the null hypothesis is not rejected based on the evidence, and under such condition it would not be correct to conclude that since the null hypothesis is not rejected, alternative hypothesis can be accepted as valid. The third point that we should keep in mind is that in marketing research, the null hypothesis is formulated in such a way that its rejection leads to the acceptance of the desired conclusion. The alternative hypothesis represents the conclusion for which the evidence is sought. Students, there are certain problems which are associated when we are going for the hypothesis testing approach. Now, Wolfowitz in 1967 has very aptly discussed, or has very correctly tried to define the hypothesis problem, and he says that the practical statistician who now accept useless theory should rebel and not do so anymore. The problem basically that we are talking under the hypothesis testing approach is that the most glaring problem with the use of this testing is that nearly all null hypotheses are obviously false on a priori grounds. The alpha level that we usually consider, always like 0.1 or 0.05 or 0.01, they are arbitrary and without any theoretical basis. Using a fixed level arbitrary classifies results into meaningless categories, significant and non-significant. The third problem that accrues under the hypothesis testing is that the likelihood ratio tests between models that are not nested do not exist. This makes comprehensive analysis a bit problematic. The presentation of only test statistics, degree of freedom, and p-values limits the effectiveness of meta-analysis. There is a strong publication bias where only significant p-values get reported or accepted in the literature. It is important to present parameter estimates and their precisions. These become the relevant data for the meta-analysis. Another problem that is being quoted by the researchers during the against the hypothesis testing approach is that we generally lack theory for testing the hypothesis when the model includes nuisance parameters like sampling probabilities in capture-recapture models. One must be very careful in trying to infer something about the p-value, say 0.11 or 0.02, as the strength of evidence for the null hypothesis. In a real sense, the p-value overstates the evidence against the null hypothesis. The standard likelihood ratio and not the likelihood ratio test based on likelihood theory provides a more realistic basis for such evidences. Let us now have some examples which will help us in developing a better understanding of whatever the theory that we have discussed till now. The first example or the first question that you read is as a promotional activity carried out by an Ayurvedic pharma company, it may be Patanjali, propagates that its new medicine, if consumed regularly for 15 days, will result in average weight loss of more than 5 kilograms. If you want to find out whether the claim made by the company is valid or not, following hypothesis shall be tested. So what we are trying to say, we have given you a situation and now we have to develop the hypothesis, and we know that we need to develop a null hypothesis and at the same time we have to develop an alternative hypothesis. So in this question we are trying to find out that how can we frame the null hypothesis. So the null hypothesis under such situation will be that where mu is less than equal to 5, because this is the claim that is being made by the company. As a result, the alternative hypothesis for such a situation will be that mu is greater than 5, where mu is the population mean. Let us see another example. A gardener claims that by using his particular method, a plant of a particular variety may be grown to the average height of 50 centimeter. Now this is the claim which has been made. Now we will verify it. So to check if the claim made by the farmer about his technique is correct or not, 900 plants were introduced to the field and then the heights of some poppies were measured. Now we need to test this claim which is being made by the gardener. So the first thing that we need to do, we need to develop a hypothesis, and we know that hypotheses are to be a null hypothesis and the alternative hypothesis. So under this situation, what he is saying that the average height is of 50 centimeters. So here we are going to use a equal to sign. We say that the null hypothesis of mu is equal to 50 against the alternative hypothesis, which will be just the opposite of the null hypothesis. So the null hypothesis will read as mu is not equal to mu naught, where again mu is your population mean. Let us take another simple example. A microbiologist wants to find out whether a particular microorganism will grow at a different rate at 4 degrees centigrade than at 25 degrees centigrade. Given that the average number of microorganisms that may grow at 25 degrees centigrade is 3. So I hope by this time you would be able to make this null hypothesis, which will read as H naught mu is equal to 3, and your alternative hypothesis will read mu not equal to 3. Let us take another example. A trade group predicts that back to school spending will average rupees 1000 per family. A different economic model is needed if the prediction is wrong. So now develop the null hypothesis and the alternative hypothesis to determine if the alternative model may be required. Simply here we are going to use a sign of equal to, because the question itself repeats that a trade group predicts that the back to spending will be average. They are talking that the average spending would be equal to 1000 per family. Therefore, the null hypothesis read as mu is equal to 1000, and alternative hypothesis will automatically be that mu is not equal to 1000. Let us take another example with a different situation. A television research analyst wishes to test a claim that more than 50% of the households will tune in for a TV episode. Specify the null hypothesis to test the claim. From here we get an idea that while we are developing the null hypothesis, which sign we are going to use. Remember, there are 3 conditions: less than equal to, greater than equal to, or equal to. So since here we are talking of more than 50%, so our null hypothesis will be mu naught p is less than equal to 50. Here we are not using mu, we are using p. Since the values given to us is in the form of percentage, that is a proportion, we are replacing mu by the word p. And we have also seen that if the null hypothesis is less than equal to, then the alternative hypothesis will be greater than, where p signifies the population proportion. Similarly, an advertisement for a population weight loss clinic suggests that participants in its new diet program lose on an average more than 10 kilograms. Mark the word more than. So from this place you should get an idea that how you are going to form your null hypothesis. A consumer activist wants to determine if the advertisement's claim are correct or not. So specify the null hypothesis and the alternative hypothesis to validate the advertiser's claim. So I have just mentioned, since we are talking about more than 10 kilogram, so my null hypothesis will mu is less than equal to 10, and alternative hypothesis consequently will be of greater than equal to. One more question. It is generally believed that at least 0.6 means the 60%. So here we are not going to use mu, we are going to use p. So why I am telling all these things, students? Because the moment you are reading a data, you should be able to understand that whether mu has to be used, whether p has to be used, whether they are using more than, whether they are using less than, whether they are using equal to. So the moment you start reading any proposition, the moment you start reading any claim, you should be active involved. So students, here the moment you read this line, you should be able to think about that they are talking about at least. So it should not be, now we have to assign greater than equal to or less than equal to, but not of equal to sign. Secondly, here you are using a word 0.6, which means that you are talking about percentage, you are talking about proportion. So here you are not going to use mu, you are going to use the word p. It is generally believed that at least 0.6 of the residents in a small town are happy with their lives. A sociologist is concerned about the lingering economic crisis and wants to determine whether the crisis has adversely affected the happiness level in its town. Now, develop the null and the alternative hypothesis to determine if the sociologist's concerns is valid. So similarly, it's very simple. We now know that the H naught of that P would be greater than equal to 50. As a result, your alternative hypothesis would be less than of 50. So here you see, student, population, or if your alternative hypothesis, that what is the sign that we are going to use in the alternative hypothesis will be derived by your null hypothesis. Or if you are clear that what will your alternative hypothesis, then the signs that can be easily derived for your null hypothesis. So students, let us now summarize what we have learned in this module. This module provides an opportunity to the students to develop an understanding about the basic concepts related to the hypothesis. It starts by explaining the meaning of hypothesis, that it is an assumption, a preconceived notion which needs to be tested. Two types of hypotheses are developed, a null hypothesis and the alternative hypothesis. A null hypothesis is a statement that tells that there is no real difference in the sample and the population with respect to the issue under consideration. It maintains the status quo. An alternative hypothesis is one in which some difference is expected. It specifies those values that are believed to hold true and which is expected to hold the truth. The null hypothesis regarding the population parameter of interest is specified with either of the symbols like equal to, greater than equal to, less than equal to, and the corresponding alternative hypothesis is then specified with the signs like not equal to, less than, or greater than. Students, it is important to note that it is always the null hypothesis that is tested. The null hypothesis refers to a specified value of the population parameter and not of a sample statistics. Secondly, a null hypothesis can either be rejected or not rejected, but it can never be accepted based on a single test. Thank you so much.